record. So now we're recording. So welcome to this brown bag lunch, and especially welcome Nicolas Frankel that will do today's presentation. So maybe you can start by just introducing yourself shortly before you start the presentation. And you have to unmute.
Yeah, I was being polite, being muted, and then yeah. And so I'm Nicolas Frankel. I've been working with Java since 20 years. I started working 20 years ago. For a long time, I've held technical jobs, developers, architects, whatever. And now, actually, I'm a developer advocate since 2 years. Yeah, that's all. I'm actually, yeah, I mean, being a developer advocate allows me to do a lot of, let's say, prototypes, or less focused on projects and on like delivering, and more on exploring and searching and stuff, which is very interesting when you are like in the tech world. That's really all.
But I guess that's perfect.
Okay, so let me share my screen and we'll start. Yeah, here it is. Feel free to switch on your camera if you feel comfortable with that. Feel free to like ask questions. Like a lot of my time is spent right now like talking to my screen, which is not super fun. So if I can have feedback, yeah, I see somebody smiling, so he understands me perfectly. Like if you can do that, yeah, that would be very nice. Then I will be talking to people. Also, when you switch on your camera, I can see your face. Like if your face is puzzled, I can understand that something was not clear. If you feel is smiling, it might be because of my bad jokes, but I will try to avoid jokes anyway, because online jokes are never good. But well, you understand my point. So thanks to be here. Thanks for your time, like especially lunchtime, for this talk about like pragmatic app migration to the cloud. Well, I introduce myself. I work for a company called Hazelcast right now. Since it's Java user group, I assume, I infer that you might have heard about Hazelcast before. Probably you have heard about IMDG, in-memory data grids, and if you didn't hear about it, in-memory data grid is actually a distributed data structures. So instead of having your, let's say, hash map like located on your node inside a single JVM unbounded, then you can have this hash map that is like replicated or shared all over the network. We also have another product called Hazelcast Jet, which deals in stream processing, and especially in-memory stream processing. But today we will talk about the cloud gold rush, because it's really like a gold rush. Everybody wants to do the cloud. If you want to stay on premise, you're probably a dinosaur, and you will be obsolete soon. So on your resume, you must have like cloud computing somewhere. And there are a couple of actual factual reasons for that. It's not only about hype-driven developments. There are reasons for that. Some reasons might be cost visibility, and that's important. It's not about like having a lower cost of ownership, because that would be very hard to pretend. But it's about visibility. When you have everything on premise, probably you need to like create those total cost of ownership dashboard. And sometimes they are hard to create, because once you have acquired your hardware, you probably know how much it costs in acquisition, how much it costs in maintenance. But how do you dispatch the people who work on those for maintaining? Those are hard to like make it really visible. So cloud makes it like you got your bill at the end of the month, you know exactly what you spend and on what. The second reason is flexibility. If you acquire your hardware, I love this example of the e-commerce store. Probably you need to size your hardware for Black Friday, because the Black Friday everybody will need to go to your store. and that will probably be the peak of your hardware performance problems. So you need to size your hardware up to this level, and the rest of the year you're just consuming that. So the cloud provider tells you, hey, the gap between your peak hardware requirements and what you are using every day is actually like stuff that is completely wasted. So if you go to the cloud, you can pay only like what is required, and on the peak you just add more nodes, or it's auto scaling because Kubernetes solves all your problem automatically. And yes, you've got this flexibility. And finally, the last point, which I became aware only recently, is if you are a company, it's no problem like buying hardware. It's just a line in your accounts. But if you are a developer that want to start your startup, the first step, the first acquisition of the hardware is a huge step actually. So like going to the cloud lets you start from nothing and grow as much as you need. Once you've decided that for any of those reasons that you should move your apps to the cloud, there are like a couple of ways to do that. I assume that you already have some software assets. And so how do you move your assets to the cloud? The first is lift and shift. So you take your app, you put it to the cloud, you change nothing, and we will see what the results might be. The second way is to rewrite to be cloud friendly. And I believe, I hope, and we try to convince you that there is a middle path between those two. Lift and shift is as the following mindset. Hey, the cloud is just somebody else's computer. So instead of like deploying on my computer and operating on my computer, I will do the same on somebody else. And it can be relatively easy. Even now with containers, you just containerize your app, which might be a challenge in itself. But let's suppose we have a simple app. We are using the Maven plugin, which makes it like really like Maven compile and pam, you've got your Docker image. It seems like really a straightforward path. But the problem, if you just do that, then your costs might explode, and it can be a lot more expensive than you would expect. Because when you are on premise, if you waste a few CPU cycles, you don't care. If you waste your log space, you don't care. Well, you probably care when like the storage is full and there is an issue, but otherwise you don't care. So you can waste a lot of resources, be it CPU, memory, storage, you don't care. Now, when you go to the cloud, everything is accounted for, and you will care, or I mean, at least your accountants, your CFO will care for you. So that's the best case. The worst case is nothing works anymore because, well, when you design your application, actually you didn't think about this externalized infrastructure. And if you are already doing cloud development, you might be aware of those 12 factor apps principles. So there are those 12 principles that tell you, hey, this is how you should run in the cloud. So I won't delve into each of them. I've just written them right now. But when you are doing Java development, a lot of stuff is actually an issue. A lot of stuff is actually an issue. For example, normally you should declare all your dependencies in your app. Well, if you are using an application server, you're actually not doing that. Or you say, okay, then I will make it a self-executable jar. Okay, that's a step better, but actually the GVM is also a dependency that for you is a given, but in the cloud, it's not. So even a simple Java application without even thinking about the servlet API and Java EE is already an issue regarding 12-factor apps principles. So it's like using GVM normal application like defeats the second factor. Third factor is the configuration should be part of your application. well, guess what? Application server, you declare your data sources inside the application server, which makes sense. We have been doing that for a lot of years, but if it's the third factor. If you go to the cloud, if you run, probably you run in container, but even if you're not running a container, probably there is some configuration that if you have a distributed application that runs on a cluster of several nodes, then if one node fails to respond or lags or is too slow, it's killed, and then a new one is started. So you want your nodes to start up very, very fast. Guess what? The GraalVM is actually not made for that. The GraalVM is really good. You start it takes a long time to start, but then it's very smart and you can optimize the native code that is compiled according to the workload. That's the difference between static compilation. That's the reason why in performance benchmarks, the fact that the GraalVM has been for a long time competing with native executables, only for this reason. It can adapt to the workload. You change the workload, it will take a few cycles for the GraalVM to understand, and then it will compile the correct code. That's a huge piece of engineering. But if you want to kill and start fast, it's really, really bad. I mean, there is a reason why we are not really nicely using the GraalVM when we do a Maven build. Now we have like the Maven daemon, which is from the Gradle daemon, but you want to keep the GraalVM warm. You want to keep the process running. So that's not great, and defeats the ninth factor. And finally, in general, you want your logs to be streaming. If you are using Docker container, that's easy. You write everything on the std out, and then you scrap it, or you send it through any log driver you want. But if you are using a GraalVM application, you have been using, in general, you have been told, never use std out. It's the evil. It's really bad. You should write in dedicated files. And your application server also write in dedicated files. So for all those issues, it seems that the GraalVM is not a great fit. So lift and shift can really be a bad idea. And we have more performance issues, like probably you are using a framework. Even if it's Java EE, you don't need to use Spring. Probably you are using Reflection. Reflection, very, very bad. Reflection has hits on performances. And if you are doing, again, Java EE or Spring, you are doing class path scanning because you want to check all your classes that have this annotation. More performance hits. So killing your node, which hosts a GraalVM application, a web application, not a great idea. So second idea, we go on the complete opposite path and we rewrite the app. So there is something in the chat. Perhaps there is a question. No, it's a smiley. Yeah, don't be afraid to interrupt me because it's hard for me to see the chat window, you faces and my slides. So yeah, just unmute yourself if you feel comfortable and ask the question. I have no issue with that. So like lift and shift is not a great idea. So the other idea is let's rewrite everything. I mean, we are developers. We love to like put everything to the bin every time and rewrite from scratch because it makes us feel good inside and we can like do as we please. We don't need to cope with those other idiots' legacy code. We can write our own legacy code and it's much better. And of course, we will be the next generation idiots, but that's something else. But there are a couple of arguments against rewriting it. The first, of course, is the costs. Like any non-trivial application will cost to be completely rewritten. And it will be harder to like hide it under some kind of refactoring or stuff. You probably need to have a dedicated budget line and it needs to be in the open and you will need to talk to your boss or to your boss or up to, yeah, very high into the hierarchy. So there is a low chance you will ever get the budget. Now imagine, oh, Matthias has his cat. So I will take also my cat, which like scratch on my leg every now and then and say hello to my cat because it's very hard to make a talk when your cat is scratching on your leg to get attention. Yeah, so you know what I'm telling you. Yeah, you have been experiencing that. So imagine that we live in a nice world and your boss is let's say, I wouldn't say smart, but at least he understands that if he doesn't give you the budget, you will leave, and all your team will leave. So it gives you the budget. The second problem is it takes a delay between the time that actually you start writing the app until you reach the time where you have a cloud native app that is as good, that has the same features as the legacy app. It takes some time. And during that time, do you think the business will stay put still and say, oh, don't worry, we have no more requirements. We will just like shut up for 6 months, 1 year, and we will be happy with what we have? Well, chances as the business will want to have more features inside the legacy app. So you will need to write those features also in the cloud app. So you will be chasing a moving target, which is actually the worst that you can do in a rewrite project. You want your target to really be still. Of course, there are risks because even if we are much better developers than the people who wrote the legacy app, there is a chance that somebody in the team is junior and will introduce bugs. Not us, of course not, but the intern of the month will probably introduce bugs. And so it's a high risk. And the final problem is, how would you organize your team? Because money doesn't mean manpower. So you need to find those new developers. And of course, you can recruit them, but then it will be for a short period of time, because once you have finished writing the app, probably you need to let go of them, or you need to use like outsourcing. And well, everybody loves outsourcing. Everybody loves working with people half a world away in another time zone and who have a completely different culture. They cannot say no, for example. You will need to understand that their yes means no. This kind of like cultural gap. And how do you organize them between this new workforce and yourself? Who will be tasked with developing the new application? In general, you will bring the old developers to they will need to rewrite the new application, and when you will task those like new workforce to work on the maintenance of the old application. But the new developers, they don't know these old applications, so they will probably bother every now and then the legacy developers. Well, rewriting the app is a nice idea, but actually, in the fact, it can be a nightmare. So, as I mentioned, I believe that there is a middle path, and the idea is to reuse the existing code, but in a different way. And when I say reuse the existing code, well, whether you are using Spring or Java EE, you can do both. You just like keep your code base, and you change the way they are used. And I need to, for that, to introduce something called GraalVM. Quick show of hands, who knows about GraalVM? Okay, that's good. Thanks. Well, somebody switched on his camera. So do you know GraalVM, Eric? Yes, hello, Eric. Yeah, good. Okay, good. And that's what I thought. A lot of people know about them, but for those who don't know, GraalVM actually is just a bag of tricks. So GraalVM is just a lot of different feature sets. First, it's a JVM platform, so you cannot install Oracle JDK or adopt OpenJDK. You just like install GraalVM, and it brings you a JDK, which is cool. But the real power comes from its polyglot ability. The idea is, well, we can have all those languages, and you like every language has specific, let's say, strength. For example, R in statistics and analytics, and well, C in low-level stuff, and I don't know. For a lot of reasons, you might want to use both Java and Python for machine learning, because Python has a lot of machine learning libraries, and it's really not easy to integrate them together. Probably you will need either to write in files or to make like std out towards the std in of another process. It's really not fun. So GraalVM tries to find way. So they have this Truffle Framework. So all of those languages like Python, JavaScript, or Ruby C, they have a Truffle implementation. For example, there is Truffle Ruby, and so the integration is made at a lower level. Sorry. So you have an API that allows you to call other languages from Java, for example, and then it integrates at a lower level. But what I really, really like in GraalVM is this feature called Substrate Vm. And this is actually what we would like to use inside our cloud native application. It allows you to take bytecode and to transform it into a native executable through a ahead of time compilation. Of course, you have a massive amount of limitations, like a reflection, a no reflection. And the issue is when you do your ahead of time compilation, then most of the time, if you don't configure it, by default, Substrate Vm will try to execute the code path. And since reflection is inside, it's a string, it won't know about this class that should be loaded, so it will remove it from the final executable. And when you finally try to execute the native executable, you will have a nice exception. So you need to configure every reflective access and a lot of different stuff. Also, something that is not fun is it's not cross-platform. So you should have GraalVM for Mac, it will create you a Mac executable. If you are GraalVM for Linux, then it will create a Linux executable. This kind of stuff. It can be really not fun because I tried to do it. I said, oh, I will create a native executable. I did it on my, locally on my Mac, then put it in the code container. And of course, the Mac executable was not compatible with the image. So everything needs to be inside your Docker file if you want to go this way. No security manager, I mean, a lot of different stuff. But in some use case, it can be really, really good. Like I talked about the startup time. JVM takes a long time to start up, but native is just like a native executable. So it starts much, much easier. Memory consumption, I didn't tell about it, but of course, the JVM takes a lot more memory. And remember, when you are in the cloud, you pay this memory consumption. So in that case, perhaps you want your application to be a bit less performant, but to get a lot more bangs for your bucks regarding memories. So you create more nodes, which consume like the same amount of memory totally, and then they are more performant than the one single JVM node. However, on the downside, no adaptation to the workload. So you compile statically, and you need to know about the parameters. And yes, as I mentioned, you write once, runs everywhere, doesn't work. It's not cross-platform. You create your native executable for Linux, and it will be for Linux or for Windows or for whatever. There are a lot of frameworks right now that are hyper hype, and they all take the same approach. They use this GraalVM native image to create their own Docker container, which, sorry, well, you can use the Docker container. I'm already thinking about Quarkus, but they create a GraalVM native image, so a native executable. They are leveraging Substrate Vm. And the other thing is they try to avoid accessing runtime reflections, so they prefer to do it ahead of time. You've got a lot of them right now. To be honest, I didn't check Elidon, so don't ask me too many questions about Elidon. Micronauts is like provided by Object Computing. Quarkus is backed by Red Hat, and well, Spring Boot has now since version 2.4.0, like you have the ability to create native images out of your Spring Boot application, which is really great. So you can keep everything. You can keep your code base, you can keep your logic, and you just create native images out of them. So I've talked a lot, and I need to have a demo or showcase. So my case, in that case, is a URL shortener, but I don't want to go for the traditional way. The traditional way, you need to think a lot about, hey, I will create a space about all URLs, and I will create a space about all shared URLs, and I need a way to create the bijections between the source state and to have done the collision handling. So my way is much easier. I will just generate a random link and I will store the mapping, which is much, much better. In my opinion, in my case, of course, you shouldn't do that in real life. It's easier for me. And I will store everything in Hazelcast. My stack will be a legacy Java EE application. Of course, it will be a very simple application. It won't be a very complex application. I wrote it in Kotlin because I didn't tell it's a Java user group, but I love Kotlin. I sneak Kotlin in. So perhaps you can also enjoy some Kotlin. I will be using, well, yeah, as I mentioned, like traditional APIs of Java EE, JAX-RS, and I will store the data in Hazelcast. So this is my state to start from. This is a normal application. I create a war. So here I run inside the GVM, Tomcat runs inside this GVM. And when I receive an HTTP response, then Tomcat has a lot of jars and it directs these HTTP requests to my controller inside my war. And then I have inside my war, I have a dedicated jar that knows how to talk to a Hazelcast INDG. So this is what I'm doing right now. And there are two to-be states. The first one is the to-be state in development. If you have played with GraalVM, it takes a long time to compile a trivial application. You don't want to do that every time. So in development, what I want is to still run on the GVM, and that's fine. And then I completely remove Tomcat. I create one of those self-executable jar. And instead of having this Catalina.jar, I have Quarkus. And then I also still have the servlets and JAX-RS. And I have a specific jar that is for Quarkus that knows how to talk to INDG. And in the production state, then I replace everything. Every bytecode, I replace it with a single executable. And internally, I probably looks like that, even if I have no clue. But my deployable, my unit of deployment will be this executable. And finally, some codes. Are there any questions right now? No questions?
No questions
No.
in the chat, at least.
I have the chat open.
But there's
Nothing
nothing there yet.
That's fine. I'm always worried then when there is no question. So either it can be the best talk ever, and I was so clear there can be no question, or people are, it's a really, really shitty talk and people are afraid to shame me publicly. So I never know. So if you have at least one question, I know that it's neither of them. So here I've created a POM, a project actually. So you can through the Quarkus, you have an MVN Quarkus plugin. You can create your project. This was created for me, so you can see I am using JAX-RS through REST-easy. Here I'm using Kotlin stdlib. Well, I still have tests, but I won't show them. And there is an extension. So in Quarkus, you have this concept of extension, and the command line Maven with the Quarkus plugin can add or remove dependencies. So you don't need to actually manage the POM yourself. You have this additional utility to do that. Then, as I mentioned, you've got the Quarkus Hazelcast client, and we have a dedicated test resource because we want to test our application through Quarkus. So we need to, like, it's like for test containers, you know that, you know this project test containers. You can start during your integration test Docker images, like, I don't know, a DB or whatever, because you need a DB in your tests. Here, you don't need to have this test container. It can be part of Quarkus itself. And the rest is just like nothing mind-blowing. Because I'm using Kotlin, I need to have this all open stuff. for those here, path, application scope, and Quarkus test. And I think that's all. Okay, how does it work? Well, I have this REST API. So here, I don't know if you are more familiar with Spring or with Java. To be very honest, I'm more familiar with Spring, but this lets you know that, hey, here you have a path, and inside you have a post URL, and so I need to pass something, and it returns like a plain response. So when I receive something here on the post stuff, here I have created this random thing. So I'm just telling, hey, I want a random string that only contains like normal characters and numbers. And my cat is doing bad stuff right now because it's his son. I get this random string, and if it's not there, then I will put it into this map. As I mentioned, I take the original URL, I take the shortened URL, and I store it into the map. And then I prepend a prefix, which is this prefix. I want all my URLs, my shortened URL, to be like bit.ly or whatever. Here I want it to be Hazelcast. And I also need to store the opposite. I need to store, hey, once I get a shortened URL, I want to have the long URL. So here in Hazelcast, we have this entry listener. So I store the opposite key pair value. When I get it directly as a map from the map, and I will delete it. I will delete both. I mean, the code is pretty straightforward. As you can imagine, it's nothing really hard. So here we can see how it works inside the normal GVM. So I will just need first to start Hazelcast. So we have a Hazelcast start. Yes, it works. And now I'm launching this Maven command, which launches the GVM, compile, and Quarkus dev. Well, debug through is not necessary right now, but I did some tests before. And now it's started. So right now we can test the application. So because I'm super lazy here, I will just like curl terminal curl here, and it returns me this shortened URL. And now if I do a get with this one, so I will need to get here. So why do I do this? Because I've transcoded it. So since I don't remember every time, I will just curl. Did I copy everything? Yes. So I mean, I have the mapping. It's stored. Everything works fine. Blah blah blah. Okay, that is my development environment. It works as expected. Now what I will need to do is I need to compile everything. So I have two things. I have this Docker compose file, and here, this Docker compose file is the image that of course I have Hazelcast, but I also have the image that I've created. How do you create your image? Well, when you start your application, your project, yes, you've got two Docker files. The first one is one that creates the image on the GVM, and the other is the one that creates the image native. And here, if I show you Quarkus Docker, it's already here, and perhaps I can make it a bit bigger. So here, that's the native image, 170 megs, and here is the GVM image. So as you can see, the difference is quite huge. You can also measure the performance, how fast it starts, whatever. But this is the one that was created with the native image. That's the one that is inside the Docker Compose file. So let's start it. So now I will be using another, I need to stop it, otherwise I will get an issue on, yes, so I have one member. And now if I curl again, because I'm using another Hazelcast, I will need to create a new mapping for this one. Slightly different this time. And it still works. Yep. Yes, so everything works. I won't show you how you can actually create the native image. I can, well, I won't do it actually. I can show you. This is this command line. And why don't I show it to you? Because it will be taking ages. So if I ls targets, yeah, I don't have the targets. So it will be taking a lot of time. I can start it now and perhaps I can show it afterwards to you, but it's going for a long time. So getting back to the presentation. So what I try to show you into this presentation is, yeah, cloud is good. Cloud has a lot of advantages, but it's just like the beginning of your problems, because now what are you doing with your legacy software? If you want to like just shift and lift, it's going to be a mess. If you want to rewrite everything, it's going to be another mess. So perhaps just keep your codes and just like use it in different ways. There are several frameworks that allow you to do that. Today I showed you Quarkus, and that's how you will have the biggest return over investments. Sorry, you can read my blog, you can follow me on Twitter, you can, more importantly, read about the Quarkus Hazelcast integration. So it can also show you how you can create your own extension to Quarkus. And if you are interested in the codes that I showed you, everything is on GitHub, and it's the last item. So let's check the chats, and perhaps there are questions. We want to see the code. Yeah, now I hope you see the code. Perhaps you want to see more code. What codes do you want to see more, or it was not enough? And the Git link to the repo, good question, Eric, is here. So I answered before I even read a question. That's good, like developer skill. More questions.
Could you maybe post the links in the chat?
I can do that.
That would be great, since it says otherwise I need to do that.
Look, I can post everything into the chat, so you can even subscribe to my Twitter accounts by, like, if you didn't want to but you misclicked, you can do it. Yes.
As promised, I will stop the recording, so we are in a safe space for questions. Thank you very much for the presentation.
Thanks for your time. Thanks for your attention.